Next, we have we have the next we have now there is a few properties which are dependent on two things. Okay, since charge has two things, we know that charge has two things. Charge has, let's say, charge, not let's say, we know it, charge has the charge itself is mass. So few properties which are dependent on mass and few properties which are dependent on charge. So mass dependent properties, these are really easily for capacitance, where we we're gonna next one is just gonna we can cover this after we cover series. Okay. Now, connect the battery. Okay. There are a few things that need to be there in place. One would be that the connections, they can be different connection types. Okay. Now, these connections are of usually two types. One is in series, one is in parallel. Now, what happens in this is in series, you will have this battery over here. Okay. You will have this battery here. If you connect to this, the first resistor, the second resistor, the third resistor. Okay. Now, this is going to be a negative terminal and this. Okay. What happens is the V, that means the work that is needed, more work will be needed, right? Because it says the resistor, it means it's a resistance. It means it's opposing. Right? It means that it's opposing. So what happens is that since it's opposing, we need electric potential to so that the charge can go from the positive terminal to the negative terminal. So what happens is here we have V1, we have V2, V3. Okay. Now the total V will be equal to V1 plus V2 plus V3. Okay. Now what happens is here the charges will be same. Okay. So we know from energy conservation. Okay. What energy conservation is said that energy of a closed body is always conserved. This is one system. Energy system is always conserved. Okay. Energy conservation. Okay. Now total equals Q1. Because this is the only place where it goes through, then it will be equal to Q2. Right. You see, it's going only one path. There is only one path. So how much our current is at any point will be equal to the same point. This V will get added. Okay. And one more thing, that we forgot, voltage. Voltage is different but related to electric potential. Okay, let's start again a bit. Okay, voltage is a difference between 2 points on a circuit where you are comparing, where at those 2 points you are comparing the difference between the electric potential. So let's say here we have V1 at point. Okay, when you go here, you have V2. Okay, and the difference between these two means V2 minus V1 will give us voltage. Okay, now what happens is this will remain same in series. But when it comes to parallel, what happens here is that okay. Now what happens here is that the point A is just the flipped version of the top one. Okay, this point and this point, these are exactly the same, just flipped. So since potential of between 2 points and the points are same, we can say that V1 equals to V2. Okay, and then here V3 equals V4. Okay, so V1 equals to V2 equals to V3 equals to V4. That means what? He will equal be constant because it's a constant value. It is a constant. Now, there is the main goal is that the current flows from the positive to the negative terminal. Okay, and let's say there is higher resistance. That means it gives higher repulsion. Okay, so when you have more repulsion, then you would need to overcome that by giving more charge. Okay, your it's like a let's take a glass. Okay, you have this glass. You're putting in water, right? You're putting in water. You're filling it up, filling up, filling up, filling up to the top. Okay, your goal is to overflow it. Okay, the water here means charge because from here to here, right? The current has to go mainly from here, then here, then here, right? So it needs to overcome this. That means it needs to overflow. Okay, so the value of Q will be greater than R. Okay, resistance, so that it can flow, charge. Okay, now notice that here Q1 Q is not constant. It is constant. Sorry, because it is conserved. Okay, conserved, but since we need to overflow it, so the amount of charge depends on how much resistance is present. Right, you need to overflow it. So more is the resistance, more will be the charge needed. So there is unequal distribution. That is why you can't say that Q1 plus Q2 by 2 will be your Q total because there is no equal charge, equal distribution. Distribution depends on how much resistance is present. So your Q1 plus Q2 will always be equal to Q total. Okay? This is from energy conservation, conservation of energy. Okay. Now we have capacitance. In a capacitance, instead of using a resistor, we put in a material in between, which is usually a conductor or a dielectric. Now, to understand that, we first need to understand what are conductors and dielectrics. What are this? How are these two related to each other? Now, a few materials have free electrons flowing around. Okay, so follow when charge is induced to these conducting bodies, since the electrons are free, so there are excess of electrons, so it allows the current to pass through the electrons through the body. Okay, because charge has to go through the electrons, right? If free electrons are there, it like creates a bridge. It creates a road. If the electrons are bound, that means there is no charge. If there is no charge, then what is going to there are no free electrons. Then that means it's a neutral body. Then we also know that in a neutral body, you can't exactly make the charge does not exactly go through the body. Okay. So here electrons are stuck. So when the electricity goes, okay, it does not go, it goes only 90 degrees. Okay, 90 degrees. Okay. And it goes out like, and since there is no current, okay, I think current is just how much charge is passing per second, like the strength of the charge. Since there is no charge present in the middle, and that means that there is no distortion in the surroundings. That means there will be no electric field present at all. Okay, here electric field will be present. So the EF electric field 1 will be equal to electric field I2. Okay, now here the electric field will be different because it's conducting, right? It's because if there is a change in material, then means there is a change in space. If there is a change in space, then that means the field will be different. So now we know what these two are. Correct? Now what happens is usually in a capacitor, we measure its strength through capacitance. Okay? And usually in a capacitor, the system is like this, and there is a conductor or a dielectric. Die or conductor. Okay? Now what happens is if you kind of break this into parts, okay, you got this, you got air, okay, then you got what? The body dielectric or conductor, then you got air, then you got your negative terminal. This is positive, this is negative. Isn't this the same as series? So yeah, the same rules will apply. This and this. Though for conductors, we consider that as a baseline. B is like how we have a base of kilometers, and then you will from that we can understand miles. It's like a base reference. Okay? It's a reference. So from Coulomb's law, if you by now understood the condition formula, we have epsilon naught. Epsilon naught means how much conductivity is there in a free surface. Okay? And the ratio between these two gives a state. Okay? So now here the formula kind of changes a bit because we have to find capacitance. The formula for it is P equals A epsilon naught by D. Okay. Oh yeah, I also forgot. Here Q1 equals to Q2, right? And we know that Q equals CV. Right? So Q equals let's see, Q total equals P1 V1 plus P2 V2. Right? Now V1 plus V2. or wait. This okay. We have to find the relation between C and B. So C inversely proportional to B. Okay. So this means if you are going with this relation, then that means C total equals 1 by C1 plus 1 by C2 plus 1 by C3. Okay. And then here, since V is constant, okay, then that means P is directly proportional to Q. Okay. So when we are doing Q total, we can calculate using C1 plus C2 and so on. Okay. So this is for this. Then we'll get what? 1 by C1 plus 1 by C2. Okay. Now there is some distance between this, right? Right. So we consider the distance between the substance react, no B, and let this be X. We are not considering this. Okay. This is just we don't consider. No idea why we don't consider. Okay. 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 I really okay. So yeah, when we do A, we will get something like this by A not by B plus 1 by A not by D minus X. Right. Right. This is D. This is going to be somewhere. Right. Oh, I'm so sorry. This entire this thing is X. Okay. So this area will be what D minus X. Right. So D minus X when you do this, which equals 1 by A epsilon naught by no not yet D plus D minus X by A epsilon naught. When you consider when you take this is for a conductor. If you want to find for a dielectric, we change into permittivity. So D A K epsilon this thing plus D minus X by A K this. Okay. So we'll get something like this 1 by A, and remember this is what 1 by C. Okay? A K epsilon this thing B D plus D minus X. Okay? So now what will we see here? A K E by D plus D minus X. Okay? There are two formulas. Uh, I did this derivation because it's a detail which kind of connects multiple concepts. It strengthens a concept. That's why I added this. What else do we have left? Um, okay, wait, we have capacitance, two things, then that, missing this part, not everything is clear, not everything. Missing some part, I explained that part, I explained this part, I explained this, oh, dipole is there, and this is dipole. Okay, let's we talk about dipole. Wait a second. And this, I forgot. Okay, two things left. In an electric dipole, when you place two charges in an electric field, okay, what will happen? These electric field, these charges themselves will have electric field, so these will affect each other. Okay, this affect the consequence of these two charges having on each other while they are in the electric field is known as electric dipole. Okay, now electric dipole, we got the idea. Now what is let's conductors, how you make something neutral into a chargeable like. Now there are mainly two types. So physical touch and distance. Okay. What happens is in physical touch, you have rubbing where you are literally rubbing two bodies and the electrons flow from one body to the other because of friction. Okay. Because of heat, the electrons from the molecules break and they transfer to each other. Okay. Now, one more is to conductor that we have kind of explained. If there is a neutral conductor and you give it electrons, then that will have the same charge on it. Okay. Now, distance we have induction. Now, the main difference between these two, the similarities is that these two have neutral bodies. Okay. These two will have neutral bodies. Now, what happens is, since these are neutral bodies, but the difference is mainly the type of charge that they give to the neutral body. In a conductor, you'll be giving the same charge as your uh, charged body, but in induction, it will kind of divide it into two parts. So when you bring this is a positive charge, let's say this is a conductor, because this body itself is a conductor and this is far away. Okay. So what will happen is the electrons will break and the negative part where it's attracting will go over here and the positive will go over here because it's because of repulsion. Okay. This was the concept of the entire chapter and I don't think yeah. Oh, Ghost Law. I totally forgot about it. Okay, I'll explain this quickly. Now we have a law which states that when there is an electric field going through a body of surface area, this thing, okay, so electric field is not going to be quite same because it's going through a body, so it will have some relation with epsilon naught. Okay, okay. So the electric field inside then is given by Gauss law. The formula and the few derivation of the parts is similar to other chapters. So I'm not quite going into too many derivations for now. If I feel that I missed a few details which will strengthen the concepts, then I will make a separate video on those because, and by any means, this is not a perfect representation, perfect suggestion of the lecture of the chapter, but I still hope that this will benefit you in some way. The last parts will become I'm quite tired and that's why I'm kind of do not try to simplify too much, but just try building on top of what we already had. And yeah, I'll add if there is nothing new in another video. So, thank you.